Assalamu alaikum everyone. I hope you had a good day. And what I would like to discuss today is about balancing equations according to electrochemistry, or according to the change in electrons, or according to the change in oxidation numbers and stuff like that. The very first thing that you need to keep in mind is the change in oxidation numbers. And if you want to know the change in oxidation numbers, then you need to be able to figure out the oxidation numbers themselves. The oxidation numbers can be easily calculated by following a couple of rules. One of them being that the ionic charge, if you know what the ionic charge of something, of a substance within a compound, then that substance's oxidation number is the same thing as the if that substance's ionic charge, is the same thing as the oxidation number. Similarly, if you have hydrogen present, then the hydrogen in a non-metallic compound or a non-metallic substance overall, or a covalent substance overall, will have an oxidation number of +1. So hydrogen within a covalent substance will have an oxidation number of +1, and within a ionic substance, you could say, or within bonded with metals, it will have an oxidation number of -1, while oxygen will have an oxidation number of -2. The overall charge also equaling the sum of oxidation numbers. Obviously speaking, you will not be forgetting the quantities that are present. So let's get to some examples so that you can see it practically. For example, you have a substance AHO4, A being the substance in question that you need to figure out the oxidation number for. So I've taken that oxidation number as X, and the oxidation number of hydrogen is 1, and the oxidation number of oxygen is -2. The quantities are taken into account and multiplied with the respective oxidation numbers. That will give you the overall sum of oxidation numbers, and that should equal to 0, because this is an overall neutral substance, or an overall substance that does not have a charge. So that means that X plus 1 times 1 minus 2 times 4 should equal to 0, or X equals to 7. This will give you the oxidation number equaling to 7 plus. Similarly, you can figure out the oxidation number of manganese within MnO negative, and that will be MnO4 negative specifically, and that will be same methodology. You have X being the oxidation number of manganese, -2 being the oxidation number of oxygen, and 4 being the quantity of oxygen. That should equal to -1, because the overall charge of this substance is -1. And that way you can figure out the oxidation number being 7. Now, the rules for balancing equations is dependent on the fact that you need to figure out the change in oxidation number for the substances in question. If you are able to figure that out, you have done most of the things. So for example, I have some X and Y reaction happening, and I figured out that, hey, MnO4 negative is present and Mn2 plus is present. I figured out the change, right? The change showing me that it became from 7 plus, having an oxidation number of 7 plus, into a 2 plus oxidation number. That means that it must have taken 5 electrons for it to become reduced. So that means that now I can go forward with my next steps. So the very first thing that you need to do is, 1, figure out the oxidation numbers of the specific substances present, and that way you will figure out what was oxidized and what was reduced, and that way you can figure out the quantity of electrons that was exchanged for that substance to happen. But this is a small piece of the entire reaction. Let's see what I mean. I think that you need to keep in mind is that the loss in oxidation number is gain in electrons. So as you're shoving more electrons into the substance, the oxidation number will decrease. It is going more to the negative side, and if you are taking electrons from it, it will go to the positive side. It will have an increase in the oxidation number. All right. Now, the next step is for you to be able to balance the electrons on both the equations. So for example, I have 2 equations similar to this one. I have another equation, one of them is being reduced, so the other one must have been a reaction in which it was being oxidized. So the quantity of electrons must not be balanced. I mean, it is not necessary for it to be balanced, and what our job is to balance that electron transfer. And if we are able to balance that, then we can continue on with the next steps. So after we balance the electrons, we can then balance the oxidation numbers, oxygen present, by adding water on either of the side. So if you have more oxygen on the left hand side, you're gonna add water on the right hand side. right? If you have more oxygen on the right hand side, you're going to add water on the left hand side. Basically, you're adding water in order to just balance out the oxygen, and you're adding hydrogen ions in order to balance out the hydrogen, because if you add water, then you have added hydrogen as well. If you have added hydrogen, then that means that the hydrogen will probably not be balanced, so you can balance it by adding hydrogen ions. And then the last step is very simple. You're just going to shove those two equations together, you're going to mix them all together, and you're going to get a net reaction, or an overall ionic or full ionic reaction. Let's see this in action. So in this question, you should use changes in oxidation numbers to balance a chemical equation. Acidified potassium dichromate solution can oxidize a solution of vanadium 2 plus ions. The equation for this reaction is shown. This is the reaction that is partially shown, right? You need to figure it out and you need to balance it out. So how can we do that? We're going to make two equations, right? We're going to make two equations. The very first equation is going to be A being the number of moles for Cr2O7, and B being the number of moles of V2 plus. Again, this is for the balance equation. So in this scenario, because it is an MCQ, it is not necessary for you to balance the entire equation immediately. What I mean by balancing the entire equation, I mean that you don't necessarily need to follow these steps, right? These steps are not necessary to be followed right now, because you can see here that you're only balancing the main substances. You are not basically, the question is not asking about the ratio of water or hydrogen or something like that. So you don't necessarily need to follow those specific steps right now. You can just go with the second, and that will give you the answer. So I made equations. The very first thing that I need to do is make equations, right? So first of all, I figured out the oxidation number of Cr2O7. Basically, I basically contained them together. So I have chromate on the left and I have chromium on the right. So I just took them together and I made an equation. I said that, hey, Cr2O7 2 negative is turning into Cr3 plus. This is my equation overall, but this is not balanced, right? There must be something that I need to balance this equation. So how do I balance it? First of all, I need to figure out the oxidation number. I'm gonna go over it very simply. That first of all, I know that the oxidation number of chromate is, for example, X, right? I have 2 chromates, that means that 2X, and I have 7 oxygens, that means that minus 2 times 7, and overall charge is minus 2. So that means that it will have an overall oxidation number of minus 2, or the overall sum of oxidation number is going to be equal to minus 2 as well. That way I can figure out that the oxidation number of chromium within this substance was 6. And chromium on the right hand side had an overall charge of 3 plus, so that means that it is quite simply having the oxidation number of 3 plus as well. So the very first thing that the students would do is that say, hey, that must mean that it had gained 3 electrons, right? Because it is turning into 6 plus to 3 plus. That means that there was a reduction in oxidation number. That means that this was reduced. That means that electrons were added, right? That's what it means. And they would say that, hey, this means that you must have added 3 electrons. But you need to keep in mind that the quantity is very relevant, right? But there are Cr2, right? There is not 1, it is 2 chromium. So that means that 3 electrons is gained by 1 chromium. So what you need to do is you need to have 2 chromium present on both of the sides to balance it out, right? So chromium on the left is 2, so the chromium on the right must also be 2. That means that the amount of electrons exchanged will also be times 2, or 6 electrons. We have a equation that has mildly been balanced, right? You have electrons being balanced for them. On the other hand, you can figure out the electron exchange for vanadium by the same methods. X being the oxidation number of vanadium, minus 6 being the oxidation number of overall oxygens, and minus 1 being the overall charge of that compound that we're talking about, right? The overall oxidation number that you get for vanadium on the right hand side is X equals to 5 or 5 plus. So what that means is that it became from 2 plus to 5 plus. So that means that it must have lost 3 electrons. You get 3 electrons right there. Now, what is the imbalance? So what you need to figure out yourself is what can you do or what should you do or multiply these equations with, so that at the end of the day their electron count is equal to each other, right? So what should you do? If I basically multiply this entire equation by 2, this 3 becomes 6, the electron count is balanced. So that means that the ratio, right, the ratio of V2 plus and Cr2O7 is 1:2. So the overall answer I get for this MCQ is B. Let's continue. In this question, you should use changes in oxidation numbers to balance a chemical equation. The following reaction occurs when MnO2 is warmed with dilute H2SO4. The same methodologies will be applied here as well. But this is an interesting equation because this is an equation that is known as disproportionation. A disproportionation reaction is a reaction in which a singular substance is both oxidized and reduced. And in this case, it is manganese. It is both oxidized and it is both reduced. This being reduced and this being oxidized, but you get the point. A single substance is being oxidized and it is being reduced. But students get confused again. They're like, sir, this is extremely difficult. But no, you're just gonna make two equations. You are just gonna make two equations that will have MnO2 separate, and you'll still be able to balance it out. First of all, you need to figure out what it is talking about. What is the thing it isn't asking about? It is talking about C and D. C being Mn2 plus and D being MnO4 negative. Okay, that's fine. So if I were to just balance these two equations according to the electron count, I can figure out this and I can figure out this. But again, this must be a balanced equation for the electron count. So you yourself should first of all figure out the oxidation number on both sides. After you figured that out, you can figure out the change in electrons that had happened for this oxidation change to happen. And that way you can figure out that, hey, MnO2 plus 2 electrons should equal to Mn2 plus, and MnO2 giving 3 electrons should give us MnO4 negative. What should we do for this so that at the end of the day this overall equation is balanced? Well, quite simply said, if I multiply the upper equation with 3 and at the lower equation with 2, it's gonna have a balance thing, like a balance equation, right? Both the equations will have the same amount of electrons transferred, so the equations have been balanced. A good way to figure it out is by looking at each other, right? Looking at the second equation and multiplying that number count with the first one, and looking at the first equation's number of electrons and multiplying that with the second equation's number, or the ratio of that will tell you. All right, so the if you were to take a look at the first example, if you were to look at it here, what is the ratio of the two electrons in the two equations? It is 1:2. So this is 1 and this is 2. So the method in order to balance it out is going to be multiplying the bottom equation with 2 and the upper equation with 1, right? So the ratio is going to tell you the answer, or the multiplication that you need to take place, right? So that way you can figure out that, hey, Mn2 plus must be 3, right? So C must be 3 and MnO4 negative must be 2. So that way you can figure out that the answer is D, right? Let's take a look at this equation. This is a very interesting question for sure. Basically, this question is giving you two half equations, and what you need to do yourself is figure out if these statements are correct or not. So let's do that. right? Let's do that. So first of all, I have this equation that is already like partially balanced, but the only thing that is not balanced is the electron count. That's the only thing that is not balanced. The electron count is not balanced. So we're gonna do it the same method. So we're gonna figure out the ratio of electrons on both the sides. It is 3:2, right? So that means that if I multiply this bottom equation with 3 and this upper equation with 2, it's gonna have a balanced overall electron count, and that's how I can balance the equations. That's what I did, right? That's what I did. And after multiplying it, I made this entire equation. So 2 times 1, that is 2MnO4 negative, 2 times 2, that is 4H2O, 2 times 3 electrons, that is 6 electrons, and 2 times MnO2, that is 2MnO2, and so on and so forth. You can make 2 simple equations. And then what you're going to do is that you're going to combine them together. So what they have done themselves is that they have already, if you were to take a look at the steps, they've already done this step and they've already done this step. What you need to do is figure out this step right here, right? If you figure it out, then the only step that is remaining is the combination one, and after that you have basically done everything. You've basically balanced the entire equation. You have an overall fully balanced ionic equation. So combine them together, and after combining them together, you can figure out some simple methods of figuring out an equation, right? So think of it as simple maths. What do they mean by simple maths? What exactly is it that they're trying to indicate, right? So what I mean is that it is literally simple addition, right? Simple addition. So for example, I have H2O on both the sides, right? So that means that if I were to talk about them together, or something, so for what I could say is that, hey, X, for example, is some of my equation, and I have 4H2O, and Y being the other remaining equation overall that I'm gonna get, whatever that may be, I don't know, and 3H2O being on the right hand side. If I were to balance it out, it will be, hey, X plus H2O, right? This goes there, this becomes 4 minus 3, and it becomes H2O only equals to Y. So this is just normal mathematics, right? Normal mathematics, nothing to be afraid of, right? This is what I'm trying to indicate. This is not supposed to be something that will be scary to you, but it's just a normal mathematics that you're gonna do, right? And that way you can figure out it for this as well. What will happen? It will have just 8 minus 6, that will be 2OH negative on the right hand side. So if I were to combine them together, what will happen is that the electrons will cancel out because they're balanced, and you're gonna have an overall equation like so, right? And that way you can figure out what each of these steps are correct or not. So U is equals to X is equals to Z. So MnO4, MnO2, and OH. Is that equal? Yeah, it is equal. Yeah. So 1 is correct. Is 2 correct? Manganese is reduced to oxidation state plus 4. If I were to figure out the oxidation state of this, it's going to be X minus 2 times 2 equal to 0. That is going to be X equals to 4. So yeah, it has indeed been reduced to oxidation number plus 4. Right? And is the last one correct? SO3 2 negative is turning into SO4 2 negative. That means that at the end of the day, it is turning from 4 to 6. That means it has basically lost 2 electrons, or it is being oxidized to 4 to 6. That means that this is also correct, right? Simple things that I have shown, simple oxidation number calculation that I have shown, right? So this is the final question, I believe. Yeah, the final question. And what we're going to do in this one is that we're going to have an overall balancing of this equation. All right. First of all, I want you guys to give it a shot. Right. I want you guys to give it a try. And then we're going to have an overall balance of this equation. So how can we do that? Same methods. First of all, we're going to figure out the oxidation number on both of the sides. Chlorine on the left and chlorine on the right, manganese on the left and manganese on the right. That way I can figure out the changes in oxidation number, right? One is in dark blue and one is in light blue. The light blue is in the oxidation equation, right? 2 electrons were lost, and the dark blue is 3 electrons gained. So that means that it was reduced. That way I can figure out two equations. One of them is isolating the chlorine and one of them isolating the manganese. I will have these two equations respectively. Again, I'm going to follow the same methodology that I've shown before. 3 goes there and multiplies with the entire equation, and 2 goes there and multiplies with the entire equation. Again, this is the ratio, right? This was supposed to be 2 and this was supposed to be 3. This is the ratio, not the exact number. This was the ratio. So if this was, for example, 6 electrons and 3 electrons like I've shown before, the ratio of them will be 1:2. So I'm going to multiply the ratio, not the overall electron count, right? So that way you can figure out the balance of these two equations, right? A simple balance equation. But now you have not basically balanced out the water, or basically the oxygen in the substances. So how can we do that? Quite simply, just multiplying them together, right? So 3 times O3, that means 3 times O times 3 times 3 overall is 9 oxygens, and 3 times 4 is 12 oxygens. So there is 3 oxygens that are remaining that have not been balanced. So I'm just gonna add 3 H2O on the left that has balanced the oxygens, right? Similarly, I'm going to do the same thing here. 8 oxygens are on the left, 4 oxygen are on the right, so I can add 4 water molecules on the right so that they are balanced together, right? Now let's talk about hydrogen. Quite simply, if I were to talk about hydrogen, I have 6 hydrogen on the left, so I must have 6 hydrogen on the right as well, so I add 6 hydrogen ions. Similarly, I have 8 hydrogen on the right for this Mn equation, so that means that I must have 8 hydrogen ions on the left so that the hydrogens are balanced, and that way I can balance it as well. Now everything has been done. I have balanced the electrons, I have balanced the hydrogens, I have balanced the oxygens, and I have balanced both of the equations themselves. Now all that's remaining is that you need to combine them together and you're going to get the answer. When you combine them together, the same thing will happen, the same methodologies, and it will be basically be 8 minus 6, 2 hydrogens on the left, and 4 minus 3, that is 1 water on the right. You're gonna have an overall equation like so, and this will give you the answer for W, X, and Y. This was not supposed to be, you don't necessarily need to do the entire equation for this MCQ, but knowing how this was done is important for the MCQs that you need to figure out the entire equation for. So I hope you guys figured out and understood how this came to be, or how these answers came to be, or what the methodology is, and you guys have no issues with this, because this is a question that is very often coming in the paper and basically becomes very troublesome for the students. So I hope this video was helpful to you. Keep in mind that sharing this video for others as well, it's going to be helpful, and like and subscribe. I hope you guys enjoyed this video. Allah Hafiz.